morning, all of you. I'm Amanjeet Singh, and I work at this company called as Gojek. So we are based out of Southeast Asia, and we majorly provide services with commuting, ride biking, food ordering. So it's kind of like all-in-one kind of app. So today I'll be talking about the most heated battle that is going nowadays, that is between Coroutines and Rx. Both of them like try to solve main problem of the asynchrony. So before actually deep diving inside the battle and witnessing the rounds, we'll first introduce our players, the reactive extensions and the coroutines. So if I define reactive extensions in simple 3 words, it is basically push-based updates. So you as a subscriber will subscribe to a source stream, and as soon as there is a change in the source stream, you will be getting notified about it. So for example, in this code snippet, you will be subscribing to this source stream of the shows API. You can provide the show's name, and subsequently you can get the characters. And as soon as you subscribe to it, you can get the results, you can post it to the UI, or you can accordingly handle your errors. So you can think of this certainly like you are connecting some pipes together, which is your source stream. And as soon as you subscribe to the results, you let the water flow down and transformed water flow down and consume it from the below. So this is beautiful example quoted by Ben Christensen, who is one of the major contributor towards the reactive extensions library. And now if I introduce about Kotlin coroutines, so in simple 3 words, it can be described as non-blocking subroutines. So if we go back to the old school and if we define what subroutines are, they are simple functions which we can call from the main functions. So for example, if you call ABC function from a main function, so by default, these all subroutines are blocking in nature. So that means that unless and until the call of this ABC will not execute, the main function will not resume. And on the other hand, when we talk about coroutines, they actually suspend your execution, and they not necessarily will block your code. So let's see the previous example in the coroutines world, how it will look like. So this is the same example to get the characters which we were seeing in the reactive extension slide. Now this is more like your imperative style of coding, which you do on the daily basis. But how is this solving your asynchrony problem? This is an imperative style of coding. There are no callbacks, there is nothing, but still it is solving an asynchrony problem. So let's see it. So when your Kotlin compiler works with coroutine, so it establishes a kind of state machine. So as soon as you will place a coroutine builder, there will be a state machine start. So you'll mention your coroutine scope, which basically determines your lifetime of your coroutine. You mention a coroutine builder, which can be a launch or which can be async. Then you pass a coroutine context. Coroutine contexts are basically the building blocks of coroutine, which determines the dispatchers, which determines where it will be dispatched, and determine the parent of the coroutine. And you can also define the exception handling strategies. Now, as soon as we'll be going to this fetching show of the lines, we'll suspend the execution. The Kotlin compiler will actually save the context of the coroutine. It will save the input of the function, and it will also save the next state it wants to achieve. It is currently in the 0th state, and now it wants to achieve the first state. And this get show by name will be marked as suspend inside your API interface of your retrofit. So now we have the context saved, but how it will know that what to execute when? Like the characters, like fetching the characters line, how it will know that when we have to move forward, like the function that is done by the callbacks. Now this is something which is solved by continuation. So you can think of continuation as the lines which you want to execute after the action of the function. Now when you see the suspend function, it will be modified, and the continuation parameter will be included in the second parameter when you see the bytecode. So as soon as the call of this get show by name is finished, this continuation will help you to resume the line of your code. Now similar thing happens when it will go to the first state. It will save the result from the previous state, and it will also save the state that it wants to achieve next. Now, it will similar in the way like for fetching show, it will wait as soon as this call will finish, it will move to the next continuation. Now, as soon as we have the result from this characters thing, we'll push a different coroutine in a main thread, and we can easily post the results on a UI. So now we have our result, and you can definitely show it in some recycler view or whatever the results that you like. So now let's move towards the battle. But before moving towards the battle and before witnessing the round, I want to talk something about complexity. So we as software engineers, we strive to find the most optimized solution towards our problem. But what happens is that instead of the implicit complexity of a problem statement that the problem brings itself, we tend to add explicit complexity of the framework and the library. So you should definitely know that this framework or the library one day will surround your surface area of your project. So you should actually smartly choose your framework or your library. So this brings me to this quote by Venkat Subramaniam, who tells us that you should not walk away from your complexity. You should actually run away from it. So let's start the battle and let's witness the rounds. So the round one is initial combat. So this is all about HTTP networking. So when you will do HTTP calls over RxJava, you have to include a call adapter factory of RxJava, which also takes an implementation in your Gradle file. And then you are good to go with this retrofit builder. And if you do the calls, it will look something like this. For this, you have to have the like knowledge about the subscribe on, observe on, or any other operators. So definitely, this needs some knowledge about transforming operators or maybe the thread switching operators. And then when you subscribe to the results, you are good to go. And when I talk about HTTP networking over coroutines, this actually does not need any change over retrofit or some call adapter factory other than this, because it has implicit support over coroutines if you are using the latest versions. So definitely this is the win. There are no changes, so you are winning here. Now, the call for fetching the theatrical movies will be very easy. This is something like a very imperative style of coding. So this is very easy to understand. You don't have to learn about any subscribe on or observe on here. You can simply read it and you can say that you are fetching the movies and you are trying to show it on your UI. Then there is this graph. When there is no, increase in the number of operators, you tend to increase your learning curve. So you definitely guessed it right. I'm talking about RxJava. So now there is next graph, which actually tells about the number of methods that we are going to add when we have IO reactive library and we have Kotlin Coroutines library. So you definitely will reach multidex sooner when you'll add IO reactive X library, because it adds around like 11,000 methods, and Kotlin Coroutines library is very small, like 3,000 methods. So what will I say is that if you are doing some simple networking calls and you don't have very complex transformations over your results, you can definitely use Kotlin Coroutines library. So I'll grade accordingly in this round. The RxJava will be more near to the most, because it definitely needs a learning graph over the operators. You must have the learning over the transforming operators, timing operators. But on the other hand, Kotlin coroutines are very easy to use. It relies upon the Kotlin APIs for transforming the collections. So they are very good to go. Now let's move to round two. This is all about exception handling. So let's understand about error propagation over RxJava. So if I consider this stream of 1, 2, 3, 4, 5, and if I map this according to this function, this will crash on this fourth marble. So I can pretty much say this, that the errors in RxJava are very much destructive. So if there are some error in any point of time of your stream, the subsequent marbles will not execute, subsequent stream will crash. So there are these two guidelines which people generally follow when they are coding in RxJava, and so you have pretty much good amount of operators in RxJava. You have on error, you have on error return, you have good amount of operators. And then there is this wrapping of your response in some kind of object, which actually prevents you to sudden death of your stream for upcoming streams. Like I'll show you with the example. So if this is a get movies call inside your repository and you use your API client to get movies, you easily map this to result.success, and on the error return, you will map this in a result.error. Now, let's imagine if there is an error here. So you have wrapped the result in some kind of object. Now, when you will be subscribing to this observable in some view model, now this upstream will crash in here, but the stream inside the view model will not crash because it has some kind of object still. Now, let's go to error propagation over coroutines. Now, before understanding the error handling of coroutines, we have to understand that how coroutines are they're behaving when there is an error. Now, coroutines have some kind of parent-child relationship when you use them in a view model or any kind of thing. So now, when there is some error in that tree, so like let's imagine if there is an error in right leaf, now the exception bubbling tendency would be traveling upwards. So when there is a crash in that right leaf, it will try to crash the above parent, and as soon as there is crash in the above parent, all the running coroutines will be crashed. So I can pretty much say this, that exceptions are like virus for the coroutines. Now, if I talk about error handling over coroutines, there are these 3 rules which I generally follow. So it actually depends on what coroutine builder you are using. If you are using launch, there is a separate exception handling strategies. If you are using async, there are some different strategy. So now there are these 2 like very simple tools for handling exceptions. There is simple try catch, and then there is this coroutine exception handler. And now the third and the most important one is scope intelligently. So this scope is actually defining your lifetime of your coroutine. So let's say if you are dispatching a coroutine in a view model scope, and you have a different coroutine dispatching in a global scope. Now, if you have proper error handling strategies there in a view model scope, and you dispatch a global scope coroutine which has some error, now this will crash because you don't have any exception handling strategies inside your global scope. Now, let's do this with this some example. There is some basic setup. We define a coroutine context with a parent job and a dispatcher. We have a custom coroutine scope, and we have a suspend function which actually mimics some long running task, and we have explicit exception thrown of illegal argument. Now, if I use a launch coroutine builder and if I use this long running task, the exception bubbling tendency would be going upwards. It will try to crash that scope.launch. Now, what can I do here is that I'll use this coroutine exception handler. I'll install this, and as soon as it will try to crash that parent, the errors will be logged. So now you can send this error to your Crashalytics or somewhere, whichever platform you are using. Now, when I talk about async, now here the twist is that you will be using await. So async actually gives you a deferred result. Unless and until you will be installing a await there, it will not evaluate that the call will be having a success or a failure. So in this, you definitely, the exception bubbling tendency will be going upwards. So now this actually needs the both, the coroutine exception handler also and a try catch also. Because if there is some failure inside that await, that will be caught at that catch. And as the exception are still traveling upwards, so that will be logged inside your coroutine exception handler. Now let's be a pro and let's create a API call, centric API call inside your project. So it takes a suspend call block, and which returns a generic result object, and it has an error message. And inside that function, I'll just create a try catch, and I wrap my result with the error when there is some error. So what do you think? We are pro now. Like if we use this API call function somewhat like this, what do you think? We are pro? Actually, the answer is pretty much no, because there are many things to learn about exception handling when it comes to Kotlin coroutines. So there is something called as supervisor scope. So you definitely won't want this nature inside your project that if a coroutine will crash, it can affect all of the other coroutines which are running. So this is somewhat which is prevented by this supervisor scope. And some people actually have different type of strategies to handle exception when it comes to the Kotlin coroutines. So I have seen people using some custom interceptor inside their retrofit builders, and there are some try catches here. So there are no single guideline to follow when it comes to Kotlin coroutines. So I am grading accordingly in this round. Definitely, this is more complex. You have to understand all the error propagations and all. So let's go to round 3. Let's zip them. So I'll be trying to use zip operator here, and let's see who is going to win here. So in RxJava, we have a zip operator already there. So if I want to zip these two networking calls to get the popular movies and get the now playing movies, you can easily go forward. You can install a buy function. There is a zipper function for this. And you can get your popular movies and top rated movies inside that Lambda, and you can filter them. Now, I have a test rule here, which I'll be applying. So, which says that if it comes to threading, like it is very easy. If you have knowledge about subscribe on, if you have knowledge about observe on, you can easily switch your threads and you can easily have a smooth transition over your threads. Now, when it comes to exception handling, you can do it very easy because you have ton of operators here. You can place a on error return inside the individual level of get popular movies and get now playing movies, and you can get to know what error can be there. When it comes to scalability, so basically if you want to scale these two calls over n number of calls, you can do that also, because there is some n function, n zipper function. If you want to scale this to like 3 calls, this can be easily done. So there is a try function, there is some n function also. Transforming results. So when it comes to transforming of the results, you have transforming operators, you have timing operators. So if you have knowledge about them, then I don't think that someone can stop you from using RxJava. Now let's go to coroutines. So you don't have zip here. So definitely we need to cook it. So let's cook it then. So this is custom zip which I have written. So it actually takes 2 deferred calls and a zipper function, lambda, which I'll be using. Then in a coroutines, custom coroutine scope, I'll be defining this async, which basically calls this zipper, and it will await for those 2 deferred call to finish. Now, if I use this zipper and if I zip these calls, I can easily get my results. I'll place the await, I'll have a success, and I can get my filtered result. Now, let's evaluate according to that test rule which I created. So threading here can be done easily because you have the coroutine context in which you can define dispatchers, and that can be done. Exception handling, like I don't need to revise the round 2. Definitely it can take a knowledge graph, because you need to understand how exceptions are traveling here. So you need to understand where to put your try catch, where you need to put the coroutine exception handlers. So definitely this is something which needs time. Then there is scalability. So now you have created a custom zip for only 2 calls. So if you want to expand this over 3 calls or maybe even n number of calls, you definitely need to create another custom zip. When it comes to transforming your results, this Kotlin coroutines will rely upon the Kotlin API, because it has as soon as you get the filtered results, you can easily use map and all the collections API to actually transform your results. So I'll grade accordingly in this round. So there is one opinion from my side here. So when it comes to create some custom stuff, I'm not telling that you should not create some custom stuff, but there are chances that you can fall into some pitfalls. So the guys in RxJava, they have created something for you. So they have definitely evaluated it. They have definitely fall into that pitfalls. They have they have faced all the kind of issues which can be there. But if you are creating your own, so like get ready to face some exceptions or something like that. So let's move forward to round 4, managing states. So I don't need an introduction to this slide. If you have seen this talk by Jake Wharton, State Management with RxJava, it basically tells you that if there is your code in your center, you actually need to manage these 4 things at one time. So there are asynchronous Android APIs, there is networking calls, there are storage APIs, and then there is this UI events which are upcoming. So you need to reduce your state of your Android app, and you have to deal with this all. So for this, RxJava has good amount of things. Like for if I talk from the UI events, it can easily reduce your UI events to stream through Rx bindings, and you can like from this example, you can reduce your clicks to this search event stream. Now it is rich with operators. So when I'll be getting my stream of that UI, I can easily go forward, make a search movie call. I can map it with my result, or I can use ton of operators here. Like if I need some flat map also, I can use it. So it is rich with operators. If you have a knowledge, then you are good to go. It adheres to RNFP. So RNFP is basically reactive and functional programming paradigm. So it tells you that basically if you will be using RxJava, you are forced to follow this functional programming paradigm, which basically tells you that you will have a predictable state each and every point of time. Exception handling, so you have on error return, do on error. So definitely you are going to win here, because all the errors can be easily handled. Lifecycle management. So when there is any kind of stream here, you can easily unsubscribe them. You can use auto dispose from Uber. There are many libraries. So definitely lifecycle management is also very easy. But what about coroutines? Like we don't have any kind of stuff with like which adheres RNFP with coroutines. We have to cook some custom stuff. So when I talk about state management in coroutines, I can introduce this flows. So here actually there was a gap which is filled by flows. So flows, what are flows? They are actually suspension-based reactive streams. If I create a suspension concept in my reactive streams, that can easily be replaced as flows. So you can easily create your streams and replace this with flows. It has all kind of stuff that RxJava holds. Like it is rich with operators. It is adhering RNFP. So you have a flow builder similar to what you have like in observable builders. You have map here also. You have catch also, which is basically the substitute for on error return. And here is the major win, which is basically you are now following a functional and reactive paradigm, which says that now you can have a paradigm which gives you a predictable state at each and every point. You don't have any sudden side effects. So exception handling is now very good to go, because you have this catch, you have more operators. And lifecycle management is also very good, because now Google is supporting coroutines on the next level. You have view model scope, which basically will dispose of all your running coroutines when there is a call of on cleared in your view model. And Google guys are supporting coroutines in Room also. There is implicit support in retrofit. So definitely here will be the win. But what about UI bindings? Like I have talked about everything, but you must be thinking what happened to UI bindings. So this can actually also be done here. Like you can use flows to reduce your clicks to a flow stream, and you can easily create a kind of UI binding library. But definitely then that point will come, like you have to create your own custom things, and you can fall in some pitfalls. So this brings me to this conclusion that you actually should not face these coroutines and Rx as enemies. You can think of them as like friends. So think of this something like if the Batman is working alone, you are using his power only. And if Robin is working alone, you are using his power only. But if they are working together, they can help each other, and they can definitely, the power is going to be plus. So you should definitely try, and you should use Kotlin, Coroutines, and RxJava together, and you may have some advantages. So thank you. This is my Twitter handle and GitHub. You can follow me here. And these are some important references which you can take picture of. Like you should definitely have a look on Kotlin Coroutines Slack channel. There are pretty good amount of people there. Thank you.